Schematically, here we have a traditional database system where a single server serves the clients that connect to it. We've called the server DBS1, and we differentiate clients into two groups: those that perform read-write operations on the database and clients that perform read-only operations on the database, such as statistics, reports, pattern analysis, etc. In this system, when something goes wrong with the database server, the service it provides is interrupted, much to the chagrin of customers, until it's repaired. In some cases, this system may be valid, but it won't be valid for all cases. Of course, it's not valid for large companies, banks, emergency services, and any other that require a service availability close to 100%. The solution is to configure a high availability system. We need at least another server that we have labeled as DBS2. We'll make our database server the main server that we'll call primary or master. All operations registered in our main server will be replicated to the new server that we'll call standby or slave. If the slave server crashes, nothing will happen, except we no longer have a backup from the master until we can recover it. But customers don't lose availability. If the server that crashes is the primary one, in a few seconds failover will occur. That is, the slave will become the new primary, and clients will be able to continue working as if nothing had happened. In PostgreSQL high availability slang, when a failover occurs, the standby is said to have promoted to master. Now we can recover the old master and make it the new standby. This way, we once again have a backup for our main database. If DBS1 is the more powerful server, surely we want to reverse the roles, so that DBS1 is the master again, and DBS2 is the slave server again. This process is known as a switchover. This new scheme offers high availability, but there's still room for improvement. For example, the standby server doesn't accept connections. It's simply a real-time copy of the main server, but we can enable it to accept read-only connections. That is, make it a hot standby. In this way, clients that only query the database can connect to the hot standby server, releasing that workload to the master for the benefit of the entire system. Of course, according to this improved scheme, if either of the two servers goes down, the clients will have to change their connection. That is, if a failover occurs, hot standby will promote to master, and clients will have to change their connection to the new master. In the same way, if the standby server goes down, clients that perform data mining would have to change their connection to the master in order to continue operating. This forces clients to know at all times what role each server has and if they are startup or not. How about we make the mirror system an opaque box to which clients connect to a particular IP when they want to connect to the main database, or to another IP when they want to connect to standby, without knowing which server has that role in every moment. With a virtual IP for the master and a different one for the standby raised in the corresponding server, we would have it solved. If the server goes to standby now, the virtual IP of the standby will be lifted on the master, and the clients that work with the database in read-only mode will be automatically reconnected. If the one that falls is the main one, the virtual IP will be raised in the standby that it promotes as a new master, and the clients that work in read-write operations will also be automatically reconnected without losing operability. When we recover from DBS1 as hot standby, it will lift the standby virtual IP automatically, and the clients will be reconnected to the new backup server. And again, we can do a switch over to return each server to its original role, and the clients will be of the same way reconnected to the corresponding servers. In this course, we configure this mirroring system step by step. We'll start by configuring a replica system between the two servers of the asynchronous streaming replication type with hot standby. Then we'll install and configure the repmgr package with which we can reconfigure the failover. We'll do tests to test its correct operation, and we'll learn to monitor the status of the servers with the replica system. Finally, we'll create the virtual IPs and we'll write a script for the startup or down the virtual IPs as appropriate.